So I wanted to go over the midpoint formula, and first off, I'm going to just kind of show where it comes from, how we get the midpoint formula, because the textbook just kind of gives it to you and doesn't really explain where it comes from. And the math that you do in order to get the midpoint formula, I actually think is really important, because there's a trick that you use that actually pops up in calculus, and that is used for something that's called partial fractions. So since it does use something that you're going to need later on, I thought that it would be a good idea to actually show you the math. So that way you have some idea, like, oh, this is a trick that exists. So that way when you do learn it later down the road, you have it's something you've seen before. But I'm not expecting you to have to do any of this on your own. But it does have some interesting math tricks to kind of, something that is actually helpful. So where the midpoint formula comes from is I've got this graph here, and basically you've got, let's say, two ordered pairs, and I'm going to just put them randomly on my graph. And the midpoint is basically the halfway point between those two circles, those 2 points. And it's kind of hard to kind of figure out where that would be, but if you connect them with a line, it's a little bit easier to get an idea of where that will be. So I'm going to do my best to do a good line here. Okay, not perfect, but you can basically draw a line from those 2 points, and then you're kind of looking for the halfway point. And so I'm going to just kind of eyeball it here. I don't actually know where it's going to be, but I'm just going to try to eyeball, and maybe that's, okay, that is not, I eyeballed that badly. Let's see. That looks about halfway. So it's looking like wherever these points are that I drew, that's about where the midpoint would be. It's halfway between those 2 points. And so you can draw a segment, you've got this halfway thing. So there's two ways to think about the midpoint formula. There's one that's like sort of looking at it geometrically, where if we actually drew a rectangle, so I've got my rectangle here. If you draw a rectangle, you can see that the halfway point kind of lines up so that it's about halfway in the vertical direction, and then it's also about halfway in the horizontal direction. And so the midpoint is basically the halfway point between the x values and the halfway point between the y values, if you're looking at this geometrically. And so you're looking at it in terms of, a rectangle here. And so when you find the halfway point of anything, you're just averaging the two values. So we're just averaging the x values and we're averaging the y values. So I could label my first point as x1, y1, and my second point is x2, y2. And so your midpoint is an ordered pair. And it's just the average of the x values. So you add them, divide by 2, and then the average of the y values. And then that's written as an ordered pair. So that is basically the midpoint when you think about it geometrically and you kind of visualize it. The textbook does have a proof at the end of chapter 1 where they don't prove the geometric version. They basically use they give you the midpoint formula, and then they plug it in using the distance formula to show that you've got two sections that are equal. So this is not the trick that uses the thing that you'll need in calculus. This is sort of just a visual way to look at it. To actually do it in an algebraic way to determine the equation does require quite a bit of math. It's not like it's math you can't do. It's basically everything you've learned about algebra, except for this one trick that shows up in calculus. But everything just requires basic algebra in order to get this equation a different way. So that's what I'm going to show next, so that way you can learn this other trick, or at least be familiar with it. So The way this other way looks at it is that you've got this line segment, and that's your distance. And then you've got these two segments split up from the midpoint, and we can call it distance 1 and distance 2. And if it's truly the midpoint, those two sections are going to be equal. And then this midpoint, we don't actually know the ordered pair, so we can just say it's A and B. So we don't know where the midpoint is, but we know that the distance between that and the first point and the distance between that and the second point are going to be equal. And so we're going to use the distance formula, which I will write down here. We're going to use the distance formula and some math, some algebra, in order to find A and B. So the distance formula is usually written with x1 and x2's. So x2 minus x1 squared plus y2 minus y1 squared. And that comes from the Pythagorean theorem. That's where you get the distance formula. So on my next slide, I'm going to basically start this algebraic process by writing an equation for D1, writing the equation for D2, setting them equal to each other, and then doing some algebraic manipulation to get to a point where we can solve for A and B. So don't worry too much about being able to reproduce this or the question of like, well, how do you know what to do next? Just follow along. So D1, if I go back to my picture, that is our distance between our ordered pair x1, y1, and then our midpoint A, B. So I'm going to just plug this into the distance formula. We have A minus x1 squared plus B minus y1 squared. And then D2 is the distance between the midpoint and the second point. So that's x2 minus A squared plus y2 minus B squared. So those are just those two line segments, plugging it into the distance formula. Since it's the midpoint, those are going to be equal. So I'm setting these two equations equal to each other. So it's going to be a lot of rewriting. So I have these two equations equal to each other. So we've got these equations. These are radical equations. Most college algebra classes do teach you how to solve a radical equation. And basically, to remove the square root, you square both sides. So we're going to square both sides. And that will get rid of our square roots. And so that just leaves me with what's inside. We've got A minus x1 squared plus B minus y1 squared equal to x2 minus A squared plus y2 minus B squared. So what we do at this point, this would be, for someone that's just learning algebra or, if you're not a mathematician, a lot of people are like, okay, well, what do I do at this point? So this is sort of like mathematicians are like, well, let's see what we can do. So let's expand all of these squares. So let's actually FOIL out each of these things that are squared. It's going to be very long. So I'm going to FOIL what's on the left, FOIL on the right, and then we're going to just combine like terms and kind of see where we go. So when I multiply the A minus x1 squared, I got A squared minus 2ax1 plus x1 squared. And then I FOIL out, I get B squared minus 2by1 plus y1 squared. And now I'm going to FOIL on the right, x2 squared minus 2ax2 plus a squared plus y2 squared minus 2by2 plus b squared. So we've got these this really nasty looking thing. And so the thought here, first off, let's see what we can cancel out. So I've got an a squared on both sides. So if I subtracted an a squared from one side, it cancels out with the a squared on the other side. And I have a b squared on both sides. So those will also cancel out. Then I'm left with these lots of variables here, but our goal is to find a and our goal is to find b. So I'm going to put everything that has an a and a b on the left. Everything that does not have an a and a b will be on the right. So we're just going to be adding, subtracting, moving things around to get all the stuff with a's and b's on the left, and then everything without it on the right. So I've got negative 2a1x. I'm going to do this in a different color. I'm going to add this 2ax2 so that goes on the left. So I've got plus 2ax2. Then I've got minus 2by1. And I've got this 2by2, so I can add that to the other side. So that'd be plus 2by2. And then on the right, I need to move this x1 squared, so I need to subtract that, minus x1 squared. And I've got an x2 squared on the right. And then I need to subtract this y1 squared. So I got minus y1 squared, then I might plus y2 squared. So I've just put everything on the left that has a and b, everything on the right that doesn't. And now we're going to factor. And I'm not going to factor the whole thing. I'm going to actually factor the things with x and then the things with y. So we're going to try to treat these as two separate groupings here. I mean, the things with x and the things with y. And so we're going to be factoring each of those sections. And if it helps, we can kind of rearrange it so you can see like this here is x2 squared minus x1 squared. This is a difference of two squares. I've just written it a little differently, but you can rearrange it and you can see that we've got a difference of two squares. And I can rearrange this to put the positive part in front so you can see we can factor out a 2a. And here I can factor out a 2b. So we're going to factor each of these little sections here. So that gives me a 2a. Oops. It'll help if I actually write the right number there. Then we have x2 minus x1 plus 2b. Then we have y2 minus y1. And we're factoring because we're trying to get the a's and the b's by themselves. And then these factor, I have an x2 plus x1 times x2 minus x1. And then plus y2 plus y1 times y, oops, we wrote an x, y2 minus y1. Okay, this is where the trick comes in that I want to show you because this shows up in calculus. So there's this trick that we use to kind of compare the left side with the right side. So on the left, I have this x2 minus x1. And then I also have something with an x2 minus x1 on the right. And then they have different things in front of them. So there's this and this only works if you also have things grouped with like the y's here. So we can also look at the y's. We've got a y2 minus y1, and then we also have a y2 minus y1. So I can't cancel them out because they're not in every term. We only have similarities between the x terms and then the y terms. But if we say we look at the x pieces, if they both have an x2 minus x1 and these things have to be equal, then what's in front of them also has to be equal. So that means the 2a has to equal this x2 plus x1 in order for these things to truly be equal. And it's the same thing with the y's. Since you have y2 minus y1 and these things have to be equal, that means what's in front also has to be equal. 2b and y squared plus y1. And so you notice this little pattern, and we create two equations from here where I'm going to set the fronts equal and then for the x, and then the fronts equal for the y. And this is a trick that we also use when you're doing partial fractions, which shows up in calculus. So I'm going to go to my next slide, and I'm going to set 2a equal to x squared plus, or x2 plus x1, and then 2b equal to y2 plus y1. And this allows us to solve for a and b. So I have 2a equal to x2 plus x1, and then 2b equal to y2 plus y1 from that trick. And then all I need to do is divide both sides by 2 to figure it out that a is x2 plus x1 over 2, and b is y2 plus y1 over 2. And those are the values of our ordered pairs here. That's the midpoint. And it's basically the same. I just have the x2 first, but it's the same thing. It's x1 plus x2 over 2 and y1 plus y2 over 2. So we've just algebraically found what the midpoint is, a and b, by going through this lengthy process. But then the key, and I'm going to make sure that I make this important here. This is our little trick here. That's the important part that I want you to have seen. So that way when you go to calculus and you kind of do tricks like this, you're going to be like, oh, I've seen this before. Where you can compare things, see the things that are in front, those have to be equal, things in back have to be equal, and that gets us our two equations. So I'm not expecting you to reproduce any of this. I just wanted to show you this so that you can see this trick that you'll see later on. And then just to kind of show you the kind of thinking that you have when you're doing math. And this is actually the kind of, you have to look for tricks. You have to be like, well, what if I try this? What if I try that? And this is a good skill to have in all classes. So it is going to be beneficial. But that's where we get the midpoint formula. So now the useful stuff here is to basically use it. So I just have two examples because it's simple enough to use that you don't really need tons of examples. So I have this one here with just ordered pairs, and then I do have a word problem example, so that way you can see how it's used in context as well. So we want to find the midpoint of the line segment joining 1, 4 and 8, -4. So I always recommend you start by writing down the formula. And so our midpoint formula is x1 plus x2 over 2, comma, y1 plus y2 over 2. And then you have to have it in parentheses. Do not set this equal to m. I've seen people write equals m. M is slope. So you cannot just make up your own abbreviations for midpoint. It's because m means something. So we don't have an abbreviation for midpoint. So you could use MP, or you could just write midpoint, but it's not an equation. So you really don't want to write really equal to anything. We just have an ordered pair. And because it's an ordered pair, you have to have those parentheses because otherwise you're not writing ordered pairs. So it's really key that you're using the right symbols You're making sure that everything is a subscript. Your labels are below, they're not above, they're not exponents, and you're not using M as your abbreviation because that's something else. So we need to plug in our values, and so I like to just label, it's always X1 as the first order pair, and Y1 is the second, so second one, or the numbers in the ordered pair, and then I can label this as X2 and Y2, and I just make sure that I kind of label it so that way if you have to check your work, you're double checking that you're plugging in the right numbers. Sometimes color coding is really helpful so that you can match the colors and make sure you're not accidentally plugging in the wrong number. So we're averaging our X values. So we've got 1 plus 8 divided by 2. And you average your Y values, 4 plus -4 divided by 2. So that's written as an ordered pair. I have to have my parentheses. And then we simplify. So first I'm going to add the numerators. 1 plus 8 is 9. So we get 9 over 2. 4 plus -4 is 0. So 0 over 2. And then we want to simplify further. Generally, we leave it as improper fractions, but we reduce. So 9 over 2, we're going to just leave as 9 over 2. But 0 over 2 is 0. 0 divided by anything is 0. So this is going to be 9 over 2, comma, 0. And that's how we're going to write the midpoint. We don't put it in a decimal unless it's a word problem. Generally, that's the only time we're going to work with decimals, or if the numbers they gave you had decimals. But if they gave you whole numbers or numbers as fractions, you leave it as a fraction. So are there any questions on this example? Okay, it's pretty straightforward. So here's the word problem, and this is very similar to what you'll see on the application assignment. Barnes & Noble had annual sales of $6.8 billion in 2013 and $6.1 billion in 2015. Use the midpoint formula to estimate the sales in 2014. Assume that the annual sales follow a linear pattern. So it says assume the sales follow a linear pattern, and this is specifically because when we do the midpoint, we're assuming there's a line between the 2 points. So you have to make an assumption that it's following a line or is close to a line in order to use the midpoint formula. So that's why they put that in the word problem, because otherwise using the midpoint formula may not be accurate, because if it's not going to basically follow a line, your midpoint may not be exactly halfway. So that's why that is stated there. Now, the important thing when you have a word problem is determining what your ordered pairs are. And you have to think about, if I was to graph this, where would I put my numbers? What would be my horizontal? What would be my vertical? So we always put time horizontally. Time is always going to be the X value or the T value if you think about it that way. But time is always the input. It's the independent variable because we don't get to control time. We don't have any say on that. The output and what we're observing or keeping track of, that's the annual sales. That's the Y, that's the dependent variable, because the sales depend on what year it is. What that output is depends on what happens that year. So when we write our ordered pairs, our time is going to be X. So the first ordered pair, we've got 6.8 billion in 2013. So 2013 has to be written first. And then I'm going to just use 6.8 and not worry about putting all the zeros or anything like that. Then our second order pair says 6.1 billion in 2015. So 2015 is the input, 6.1 is the output. So I have to actually write it in a different order than they give us because time is always the independent variable. So now I'm going to label my X1, Y1 and my X2, Y2. And I'm going to write down the midpoint formula again. It helps you remember. So it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. And it's in ordered pairs with a comma in between. So I'm going to plug in my numbers. So I've got x1, which is 2013, plus x2, which is 2015, divided by 2. Then y1 is 6.8 plus y2, which is 6.1, divided by 2. Now, because this is real world problems, we're given something with a decimal, we want to just put these in decimal format. So I'm going to just add my years and then divide by 2. And you're going to want to make sure that when you're doing this on your calculator, you need to have parentheses for the numerator, because otherwise it only divides the 2015 by 2. But that gives us 2014, which is the year that we're interested in. And then 6.8 plus 6.1, divide that by 2. I get 6.45. So that is my midpoint. Now, this is a word problem, and we don't give a midpoint as the answer because the question is asking what are the estimated sales in 2014. You don't give a midpoint as an answer, you give a sentence as your answer. So you would say the estimated sales in 2014 is 6.45, and then you need to include the units, and it is $1 billion. So 6.45 billion. That's how you write your answer, because an ordered pair in a real world situation doesn't make sense. A sentence does make sense. You want to be very explicit. So the estimated sales in 2014 is $6.45 billion. And so we use the midpoint formula to estimate that. And it's a good, reasonable estimate because halfway between 2013 and 2015 is 2014. So it makes sense to use the midpoint for that. Any questions? Okay, so that is basically my overview of the midpoint formula. It's pretty easy to, I mean, it's not hard to use or anything. It's just probably, it's harder with the word problems because you need to know what number goes where, and then basically to how do you give your answer in the end, and pay attention to those symbols.